Welcome to Eagle Complete course. After we learned about how to make symbol libraries in the previous video, now in this video we will continue to learn about how to make footprint package libraries in Autodesk Eagle. Footprint packages serve a super important purpose when used on your PCB layout, offering a set of paths that provide both electrical connectivity and a way to solder parts onto your board. During part creation, we will still need datasheet as our reference. So, in this NE555 datasheet, we will focus on this page. In my datasheets, it's in the 34th page. It is a mechanical data for plastic dual inline package or PDIP. It has the measurement of the real component for NE555. Here's an example of what footprint package looks like. It has some element in it. The first one is paths. The paths are the green circle on this part and are numbered according to your data sheet. When placed on a PCB, each of these paths will be connected to a trace and provide electrical connectivity for a part. The next element is the package dimension. The package dimension is the rectangular gray outline that you see connecting all of the paths. This outline represents the actual physical dimension of your part, which can help during your PCB layout process to see if you're placing components too close together. Then, there is silkscreen outline. The silkscreen outline is the rectangular yellow lines lying over the gray package dimension lines. While this piece is optional, it helps to provide a visual indicator for your manufacturer when they are assembling parts on your bareboard. The last element is the name and value. These text elements are placeholders and will come in handy during your PCB layout stage. As the text suggests, name will be used to identify the unique name of your part when you place it on your PCB layout. And value can be utilized for things like labeling the resistance of a resistor, capacitance of a capacitor, etc. Now, to start creating the footprint package library, we can open our personal library we made before in the previous video. Open Autodesk Eagle and stay at the control panel window. Select the arrow icon to expand the main libraries, then right-click your personal library and select Open. Choose the footprint icon to open the Edit dialog. This window will pop up, and now I'm going to enter a name for my footprint package in this column. I will name it NE555 underscore PDIP8. Then select Yes to confirm you want to create the new footprint package. Then you will be directed to this window. This blank canvas here is where we will make our footprint package. And there are some tools here on the left-hand side of our screen. First, let's change the grid size. Changing the grid size will allow us to quickly and precisely place paths according to the datasheet measurement. So, select the grid icon in the top left corner of the interface. In the grid dialog, change the display from off to on. Next, change the size from inch to millimeter and enter 0.05 as the value. Select OK to save the grid settings. Now, we will also open the datasheet during the process. First, we will need the paths for our footprint package. Since we will be making the through-hole footprint, so we're choosing this green icon here. If you want to make a footprint package for SMD component, then you can use the icon next to it. To edit the path, click this information icon here, then click Add the path to show the properties of this path. You can edit the parameters here. The first pin in the NE555 is the ground pin. I will change the drill of the pad to 0.8 mm, and I will keep the shape to be square. Here, you can also change the diameter of the pad, but for now, I'm going to make it auto, which means it follows the drill dimensions. Next, since NE555 has 8 pins, so we will drop 8 pads here. I'm going to place them here for this moment. Now, for the second pin is Trig. Right-click here and select Properties. Now, change its name to Trig. Pin 2 until pin 8 will have round shape with a 0.8 mm drill. We will set the position of the second pin to 0 and minus 2.54, since the distance between each pin is 2.54. Repeat this process until the fourth pin. For the Y position, we can simply multiply 2.54 by 2 and 3. So, we're done with the first row of NE555. For the second row, based on the datasheet, the distance between the first row and the second row is 7.62 mm. Now open the properties of the fifth pin. Change the name to CTRL. Then, for the X position will be 7.62mm and the Y position will be minus 7.62mm. Now, you can repeat this process to the rest of the pin. And here's how our drill position in the NE555 footprint package will look like. The next step is to add the origin point of the footprint. We need to add an origin point to pad 1 so that the manufacturer knows the correct way to orient our part during assembly. First, select the circle icon on the left-hand side of your interface. Change the width by clicking the drop-down here and select the smallest width. Then, select the layer drop-down at the top of your interface and select Layer 21 T-Place. To make a circle, left-click on the canvas and move your cursor to the right to adjust the size of the circle. Then, left-click again to confirm the size and place it. If you want to move the origin point, click this move icon. The next step is to add our package dimension. Package dimensions will help us to see if our parts are placed too close together on our PCB layout. If we take a look at the datasheet again, we will see that they show us the exact physical dimension of your part as it will appear in physical form. Most package dimensions come with tolerance, which is why there's a fraction-looking number for each dimension measurement. The top number is the maximum value, and the bottom is the minimum value. The value outside the parenthesis is using inches, and the value inside the parenthesis is using millimeter. For now, I will be using the minimum value, so the length is 9.02 millimeter and the width is 6.10 millimeter. To make the package dimension, select the line icon here and change the layer to 51T docu. Then, You can start making the package dimension like I did here. Now, we're going to the next step. Adding the silkscreen outline. The silkscreen outline is a helpful way to tell the manufacturer where your part will be placed. First, select the wire icon here. Then, select the layer drop-down and choose Layer 21 T-Place. You can trace the package dimension to draw the silkscreen outline. The last step is to add name and value placeholders. This will allow Eagle to create a unique identifier for each and every part on our PCB layout. Now, select the text icon. Then, in this column, enter Name. Then select OK. After that, select Layers drop-down and choose Layer 25 T names. Then drag the name over the top of the package and left-click to place it. We can press Escape to easily back to the text placement mode. The next step is to type value, click OK, and change the layers to 27 T values. Place it on the bottom of our package. Now, our Footprint package library is done, and we can use it on our design. For addition, I will also tell you how to import external library to our Autodesk Eagle. Here I use NE555 as an example. In case we don't have much time to create our own library, we can also import someone's library to our Autodesk Eagle. Now, I will open my browser and search for NE555 Eagle library. I will visit the Snap EDA web. This is a library by Texas Instruments. To import it, first you have to download it by clicking here. Now, it will offer you some download formats. Since we're using Eagle, choose Eagle. You will be asked to sign in so you can download the file. If you didn't have the account, you can sign up first. After you log in successfully, repeat the process and the file will automatically download to your computer. Next, open the folder where you download the file. In my folder, there is a NE555p.lbr here. It is very easy to import the library to Autodesk Eagle. We just have to drag it to the libraries folder in the control panel. Once it's in there, right-click it, then click Use. We can tell that this library is ready to use if there is a green dot next to it. So, that's how we can make our customized library and how to import the external library to our Autodesk Eco.